let us jump into our next event. We are going back to the ocean. Earlier today, we spent a little time with Colin Simpendorfer and we went into the world of the shark. And then I think it's time to go back for another little bit. So we have Jodie Rummer joining us. She is an associate professor of marine biology at James Cook University in Australia. And she's the chief investigator of the Physio Shark project. So she's also been recognized for the work that she's doing in various ways, from the highly prestigious UNESCO L'Oreal Women in Science Fellowship for Australia and New Zealand, giving TEDx talks. In 2016, she was named one of Australia's top 5 scientists under the age of 40. So let's bring Jodie in live with us now. Hey, Jodie, how are you?
Hey, Joe, how are you? Very good morning for you, early morning.
It is very, very early in the morning, but yeah, I mean, how can you sleep with all this action happening from all over the world?
So exciting. Yeah. Thank you so much for having me.
Of course, we're thrilled. I'm really excited about the topic that we're going to dive into tonight. So I'm going to let you take over for a little bit and then we'll grab some questions.
Great. Thanks so much. All right. Are we ready to go? Good morning. Good afternoon for some of you, and it's evening. I guess wherever you are on the planet. My name, as Joe mentioned, is Dr. Jodie Rummer. I'm an associate professor of marine biology here in Australia at James Cook University with the College of Science and Engineering and the Center of Excellence for Coral Reef Studies. Here we have a whole center devoted to studying coral reefs, which is pretty appropriate given that we are situated right in the middle of the Great Barrier Reef. Now, I don't work on coral reefs directly, though, as you may have guessed, but I do work on a group of animals that are absolutely critical to the health of coral reefs and marine ecosystems worldwide, sharks and other fishes. And in fact, I've been here leading a research program and team called Physio Shark, as Joe mentioned, since about 2013. And I'm extremely honored to be part of this year's Global Biodiversity Festival. Today, I'm going to be introducing you to a very tough shark species that perhaps you have in your mind looks something like this shark here. But I aim to challenge your preconceptions as to what a tough shark is supposed to look like. And I'm also excited to take you all on a journey to some of the places I work and where the mysterious tough shark species is teaching us scientists a lot about climate change and what it means to places like this here on the Great Barrier Reef. The largest continuous coral reef ecosystem on the planet. It spans 2,300 kilometers or nearly 1,500 miles along the east coast of Australia and encompasses the size of countries like Italy or Germany. And even though coral reefs only occupy less than 0.5% of the Earth's surface, they are like the rainforest of the ocean, and they are vital for this planet's health. They also host 25% of all marine species. And here, the Great Barrier Reef specifically hosts 1,625 species of fishes, which includes 133 species of sharks and rays. But as you may notice from my accent, I was not born and raised here in Australia diving these gorgeous reefs. In fact, this is where I grew up, surrounded by cornfields in the middle of the United States. Illinois, to be exact, very far from sharks and oceans. This is literally my parents' backyard. Did I always want to be a marine biologist, or more specifically research sharks? In hindsight, I think I really did. This is me as a kid. Fast forward to today, and I study stress in fish and sharks. And looking back at this photo, all I can think about is how I was probably holding that fish out of the water for way too long, making it quite stressed while my dad took this photo. So that may have been the very beginning of my career, going fishing with my dad, and of course, watching beautiful documentaries on TV about the ocean, sharks, and coral reefs, and looking up to some of the epic humans that have been speaking as part of this year's Global Biodiversity Festival. Those are the things that inspired me to follow the career path to become a marine biologist. Fast forward to today, and I'm actually convincing everyone that this is the toughest shark on the Great Barrier Reef. And of course, one of my most favorite species. On the left is a photo you would have seen earlier in one of my earlier slides. It's a newly hatched Epaulette shark, and on the right is a fully grown adult. And speaking of programs that really inspired me growing up, let me get this this to work. Sir David Attenborough really helped put a spotlight on this species and will certainly back me up when I say that this shark is tough. Indeed, the species can survive and thrive in the shallow reef flats and crevices, and if it doesn't like certain conditions, it literally walks away to find better conditions. So, can this arguably cute, and I aim to also convince you tough shark withstand the stressors that are coming with climate change? Now, the fishes in general make up about 31,000 or so species. Over half of all animals on the planet today that have a backbone are fish. And they occupy nearly every body of water on the planet, too, meaning that they are influenced by water quality and therefore have a tremendous capacity for adaptation, for adapting to changing conditions in their habitats. Of the fishes, nearly 1,200 species are sharks and their kin and their relatives. And they have nearly 450 million years of evolutionary history. They have endured the ice ages, warming periods, time when the ocean's oxygen levels were very high or very low, and times when the ocean's carbon dioxide levels were 15 times what they are today. The sharks have even persevered 5 global mass extinctions, all 5 of them, including the one that wiped out the dinosaurs. So we think that we can learn a lot from this group of animals, and especially in terms of coping with climate change. So that begs the question, how do we measure stress in sharks? How do we measure if they're coping with climate change? Physio Shark is the name of the research program that encompasses all of the shark research that me and my team do, and where all of my cool shark stories come from. The name comes from 2 words. The second, of course, you know. But the first comes from physio. Now, many of you might think of physio as in physiotherapy. As humans, we might go to a physio to get pain, injury, or disease treated through exercise, massage, movement, and manipulation. Although I've had to maneuver and manipulate myself around sharks a fair few times, the physio actually stands for physiology. Now, I'm a physiologist by training. I love sports. I love athletic performance. In the most generic sense, physiology is a branch of biology that deals with the normal functions of living organisms and their parts. But this can include the muscles, the heart function, digestion, kidneys, bones, reproduction, blood flow, and oxygen transport or breathing, and even brain function. Now, that's a lot. I focus my research only on a couple of these areas, mainly those associated with movement, breathing, blood flow, and metabolism or energy use. Athletic performance, so to speak. Okay, sure, sharks don't need to be athletic for an Olympic gold medal or to improve their good looks like we do. Sharks have to be good athletes to basically eat and not get eaten. And for some, this is more of a challenge than others. They have to breathe oxygen to swim and move, to digest, and to find a suitable mate, to reproduce, and ensure a next generation so that populations and species persist. They have to be fantastic athletes to survive. And this is one of the main reasons we've been focusing on the super tough Epaulette shark. So come along on a journey with me to my aquatic office, so to speak. The Epaulette shark is endemic to the entire Great Barrier Reef, meaning that this species is only found here. Some of the best places to find Epaulette sharks are near Heron Island, where most of our fieldwork on this species takes place in the southern part of the Great Barrier Reef, But with lab work happening back up here where this yellow star is in my lab at James Cook University. So let's check them out. So indeed, probably the best place to see epaulette sharks is off of Heron Island in the southern Great Barrier Reef, where we do a lot of this field work. So I think it's important that we take you there. Epaulette sharks belong to a group called the carpet sharks. I like to think of them as crawling along the carpet, which is kind of what they do. They're even called walking sharks, as we saw in David Attenborough's video, because they can use their fins to sort of walk along the reef flats. And as you'll see, they can also hide pretty well in the corals, some of these little nooks and crannies, presumably to stay away from predators. And as you might have guessed, these sharks aren't very bitey. Their best defense is their ability to hide in shallow, small spaces. In fact, that's what makes us want to study them. They're already creating really challenging habitats for themselves. Oops. Technical difficulties.
Is there supposed to be a video, Jodie?
Yeah, it just stopped for a minute there. So we're going to play the first couple minutes over again, take you back to the Great Barrier Reef. So their biggest defense mechanism is hiding places, and they've got to be good at coping with some of these challenging conditions because they're creating these challenging little microhabitats for themselves in these little nooks and crannies in the reef. So these little nooks and crannies might decrease in oxygen, they might increase very high in carbon dioxide, and even living in the shallows, they're going to experience some really, really warm temperatures as well. So we think that they are a great species to cope with climate change. Plus, they develop in eggs that are fertilized internally. The mother deposits these eggs on the reef flat for about 3 to 4 months. And during this time, the embryo has to tolerate whatever conditions are happening around it. It can't swim away. So we can raise these eggs in the laboratory under different climate change conditions, monitor their health, their growth, their development, their tail movements, their gill movements, how much oxygen the embryo is breathing, and how fast the embryo is consuming the yolk, which is this big round circle. And we can do that under current day conditions or elevated carbon dioxide levels to simulate ocean acidification. And we found that this actually does not affect the embryos in any of these traits, which is really, really interesting. It means that they're tolerant from very early on. But what we don't know yet is all of the ways in which temperature affects their development in the egg. And we think that that might be one of their biggest challenges now and into the future with ocean warming. And in fact, we're doing a lot of work with temperature now, not only with the eggs and the hatchlings, but also with the mother sharks as well. You can see these hatchlings crawling along the bottom of their aquarium, looking for little bits of food, and even sort of walking along the bottoms of the tanks as well. So not only in these hatchlings, we're monitoring how much food they're eating, how much they're growing, but also how long it takes them to grow up to become adults. Now, as adults, we're looking at some of the pregnant females, the females that have eggs, and we even use ultrasound technology, what's used on pregnant women, humans, to see how many eggs our mother sharks have. Now, we started this research investigating how these sharks would cope with ocean acidification, and it turns out they are really tough, very much a product of their very shallow environments. But let's not be fooled into thinking that these sharks are super tough to climate change. And that's what a lot of the media sort of picked up, this shy epaulette shark to thrive from climate change just because they could cope with carbon dioxide. It seems that temperature is an issue, and we're exploring that more and more and more over these coming days. One of our earlier findings was that when we maintain shark eggs at either current day, which is in panels A and C, or climate change temperatures in B and D, and examined what the hatchlings look like, the warm water hatchlings didn't have as pronounced patterning and that prominent circle on their cheeks. We think that that may be a problem for them when they try to hide or try to fool predators, as these big circles on the sides of their cheeks are meant to scare off one of their main predators, birds. So as the oceans warm, this could really be a problem for this species if it has to come out of its hiding spot for any reason. So we continued this research led by one of my current PhD students, Carolyn Wheeler. Carolyn raised Epaulette Shark eggs in either current day temperatures or two different temperatures corresponding to mid and end of the 21st century with ocean warming. And what she found was really alarming. The warmer the conditions, the faster things happened. Embryos consumed their yolk, in other words, their food whilst in the egg, faster, they grew faster, they hatched sooner, and they had a lower capacity for exercise, and they were hungry when they hatched. They needed to search for food right after they hatched, whereas their current day temperature counterparts had a bit of time to still nourish themselves with that remaining yolk that they had internalized into their bodies, and maybe a bit more time after hatching to learn how to hunt and how to evade predators, essentially how to be a shark. We are now rewinding back to the mothers to see, as I mentioned, what is the cost of reproduction using those human ultrasound machines to monitor how many eggs the mothers are producing, what kinds of effects elevated temperatures have on egg numbers, the hormones that are involved, and the mechanistic basis to this physiological performance that's so important for these sharks to survive, and even the seasonality and the timing. This is going to have broad implications for populations and ecosystem health. Now, the Epaulette shark is known for its resilience to change, like low oxygen, as David Attenborough pointed out, and even to ocean acidification conditions, as our past studies have demonstrated. So if this tough species can't cope with warming waters, then how will other less tolerant species fare? Approximately 30% of sharks and their kin are threatened with extinction due to overfishing, exploitation, and habitat loss, making them the most threatened group of vertebrates or organisms with a backbone on the planet. Shark fin trade is one of the biggest problems. Every year, 73 million sharks are killed for their fins, and this is a trade worth nearly 400 million US dollars per year. Shark meat represents a $240 million US dollar industry per year, and sharks are also harvested for their oil and cartilage, items that aren't usually easily accounted for. Overfishing indeed is a huge issue, but about 3 billion people on the planet rely on wild caught and farmed seafood for protein, and many of these people, such as those living in small island nations, rely on fish as their only source of protein. Food-wise, it's the largest traded commodity in the world, yet 80% of wild fish stocks are overexploited and in decline. Many sharks are caught accidentally and don't live, even if they're thrown back into the oceans. So what are we already doing about this? Shark sanctuaries and marine protected areas, like here on the Great Barrier Reef, are partial solutions. They started shark sanctuaries in about 2009, and they prohibit all fishing and exploitation and trade of sharks. And today, almost 20 million square kilometers are protected waters, and this is an area larger than the US and Canada combined. This is huge. This is a really big deal because that is sharks' number one problem. But while marine protected areas and sanctuaries can safeguard sharks and their relatives from fishing pressures, they do not protect them from climate change. Today, we know that the greatest threat to the oceans and even the toughest sharks swimming, or sometimes even walking in these oceans, is human-caused global climate change. We know that this is coming from an increase in carbon emissions into the atmosphere, which is warming and acidifying the oceans. And the increase in industrial and agricultural pollution is degrading water quality by increasing sediment loads and destroying crucial habitat. Today, we're changing our oceans at a rate faster than has ever been documented before in human history. And these are the issues that my team and I have been addressing in our research on the Epaulette shark, as well as many other shark and coral reef fish species. Here on the Great Barrier Reef, waters have warmed by nearly 1 degree Celsius due to human activities since the Industrial Revolution, or the 1880s. And this has resulted in unprecedented mass coral bleaching 3 times between 2016 and 2020. While warming of less than 1 degree may not seem like much, it has been enough to kill nearly 2/3 of the corals on the largest continuous reef on the planet. What can we do? Sharks are important predators that keep ecosystems like coral reefs healthy. Without them, whole ecosystems can collapse. We need to definitely focus on curbing our dependence on fossil fuels. This is the number one solution to this problem. Education and outreach and public engagement, like what is happening here with the Global Biodiversity Festival. We do a lot of that with my team, educating the next generation of shark scientists and conservationists. Outreach into schools to talk about these issues and the importance of sharks, for example, to the health of ocean ecosystems and the health of our planet. We do a lot of public engagement such as this as well, through printed material, through presentations, both in schools and in public places. And we also published a documentary that has debuted now at several film festivals called Physio Shark. It's free to watch. You can find it by looking for Physio Shark on Vimeo or YouTube and finding us on social media as well. Now, I'd be remiss if I didn't acknowledge that this has been a massive team effort over the past almost 10 years I've been in Australia. I would really, really like to acknowledge my amazing team that's helped to make this happen so far, and it's helping me continue this passion for conserving not only shark and other reef fish species, but the oceans and the important ecosystems that they support. Now, this tough yet small egg-laying walking shark species that's found only on the Great Barrier Reef has been teaching a lot to us a lot about what it takes to endure climate change challenges. I have to leave with a question. Are Epaulette sharks tough enough? Will they adapt? Will they change their DNA fast enough to outpace the changes that are rapidly occurring in their reef habitats? And if the Epaulette sharks can't endure climate change stressors, what does that mean for other less resilient shark species? Healthy marine ecosystems need healthy predators like sharks, and those predators need healthy ecosystems. Our decisions today are really determining what the oceans will look like tomorrow. Thank you.
All right. Jodie, thank you. I know we had our discussion and we were trying to decide what topic we should pick, and I'm so glad you went Epaulette shark. I think they're such an amazing shark species, resilient and tough, and watching those baby ones walking along the bottom, it's pretty funny to see a shark doing that. Very cool.
They're the best. Yeah, we have 9 in the lab right now, like literally across the street in my lab where I am right now, and they make me so happy. They're really an incredible species. We're so lucky to be able to work with them.
Oh, absolutely, no question. And so, you talked about those headlines, and we see them sometimes, right? Like coral species that can resist climate change, or Epaulette shark that can resist climate change. Why do you think the media is so quick to grab onto these stories?
I think we need some hope. We can't have all doom and gloom. We need these bright spots. We need these hopeful stories and these tough, resilient species to catalyze our actions. I mean, I've heard a lot of people say, that want to come visit me, is the reef gone? Like, should we even bother? No, the reef isn't gone. We need to, continue our efforts, and, we protect what we love. So, it's my hope that, what Disney did for Nemo, what we can do for the Epaulette shark, that we have these species that do give us hope and do inspire us and do encourage us to do our parts to, yes, curb our reliance on fossil fuels, but all the other little things that we can do as individuals as well. We need those bright spots.
Yeah, absolutely. Now, I know that you're not always in the field. You do have to spend time in the office, and there's reports and things like that. But your other office is pretty darn cool. What's what's a typical day in the field like?
Keep your fingers away from the bitey end. That's what a typical day in the field is like. Well, with the Epaulette sharks, not as much. But here on the Great Barrier Reef, it doesn't take much to go and find this particular species. They are on the island that's, about a 20-minute ferry ride right off of the coast here. The biggest problem is finding them because they like to hide, and they're more active at night as well. We do have other challenges here in Australia, which most of you would probably be well aware. Here we've got the estuarine crocodile, or otherwise known as the saltwater crocodile, and it's sharing a lot of the same habitat, so it creates a little bit of a worry when I send students out to work in the field, and definitely a worry for me, especially if it's the dusk hours into the evenings. But yeah, that's usually when we're out looking for sharks, whether it be here on the Great Barrier Reef or my other research facility, which is in French Polynesia. The great thing is we've got beautiful places to work, and the inspirations never stop. We're constantly inspired by a beautiful sunset or a charismatic species that we get to encounter. A lot of times we're wading through the shallows, maybe up to waist deep or so, just waiting. And when we do see a shark, or when a shark hits our net, depending on the protocol, it's all kinds of excitement. We're taking all kinds of measurements, photographs, as much information as we can get. It's just such an incredible opportunity to be able to work with this group of animals.
All right. A good question here. Tracking. Do you ever tag them in any way, or are they too small? I know you could probably put maybe a number tag on, but do you ever track them in that way? See how they move through the system, through the ecosystem?
No, that's a great question. And, a lot of my colleagues, they're working on some of the bigger, more tough looking sharks, I guess you could say, are putting, tracking devices, satellite GPS tracking on their sharks. Our sharks are a bit small. What we have done, which I think is really cool, is attach just small little tags that track temperature. And so we can see what, especially because we know temperature is such a challenge for any fish in the ocean, but for these sharks as well. We could see which types of temperatures they're traversing through, and at what period of the day, and how long they're spending at some of these more challenging temperatures. But that relies on us being able to recapture these sharks. Now, with the Epaulette shark and with some of the other species that I work with, they have very small home ranges, so they can go very far. So it's pretty easy. I've got to say, this is one of the easiest species to work with in the laboratory and to work with even in the field for those reasons. It's small, it's easier to handle. They wiggle more than anything, but they also occupy small spaces. So oftentimes we can recapture the same ones. The other thing with the Epaulette shark and some of the other species that we work with is their pattern, like the big spots on the sides of their cheeks and their smaller spots and banded pattern is like fingerprints. So we can photo ID them as well.
Very cool. Very, very cool. So, you touched on this at the beginning, how important sharks are to the reef system. If you're on a reef system and there's sharks, it's probably a healthy reef system. They're important for the biodiversity. With a species as small as the Epaulette shark, do they still have a big impact?
No, that's a great question. We see the Epaulette shark as what's called a mesopredator, or in the middle, a middle predator. So yeah, you wouldn't think of that species as a top apex predator like a tiger shark or a great white, some of the larger bodied sharks. But those in the middle are really important for balance as well. Their mouths are on sort of the bottom of their bodies, and so they're scavenging up some little prawns and little crustaceans and tiny little fish that especially in the shallow reef ecosystem, that's energy flow through that ecosystem. Another mesopredator might be like a coral trout, or some of the other dynamic species that aren't necessarily a large shark species. But those in the middle are really important as well.
Yeah, I think it's all about perspective. If you're a parrotfish, then yeah, you're not going to look at it as an apex predator. But if you're that shrimp, then it's probably pretty darn scary. It's going to mess up your day. All right, very cool. So, there's a big deal made about, it made headlines, right? About are they resistant, and we're trying to find out. So, what would it mean if it turns out that they are not resistant, but they can tolerate some temperature changes or such? How does that help going forward?
No, exactly where we're going with this. So we see the Epaulette shark as somewhat of a bioindicator species. We're tracking some of these key physiological mechanisms that are associated with metabolism and blood flow and oxygen transport, their breathing and oxygen delivery that are, key to survival, key to performance. Some of those mechanisms that are allowing them to survive zero oxygen conditions, as shown in the David Attenborough video, to survive ocean acidification conditions that are coming with, the middle or the end of this century, and even some of these conditions associated with warming waters, even though they're not as good at it. But if we can find those mechanisms, then we can start to look at those mechanisms in other species, see what genes are involved as well. Now, about 40% of sharks and their relatives are egg layers. So as an egg layer as well, the Epaulette shark can give us a lot of information about some of these other egg-laying species. So we really are seeing the Epaulette shark as a bioindicator species, a species that can start to teach us about some of these mechanisms that are going to be critical for coping with these challenging conditions.
All right. What's it like taking students out with you? It must be pretty fun to have them in the field. They must get pretty excited, especially if it's one of their first field trips. What's it like working with the students in the field?
My students are my favorite part of my job. I get some amazing ideas from students. They teach me, hopefully as much as I teach them. Yeah, I think we all get into this because we're curious and just for the love of nature, and no matter how old we are, how advanced we are in our career, that's no different. And the moment that stops with me, I would be worried. And so to be able to go out into the field and feel like a kid and just be curious about just the natural world, curious about a species, how it's coping with its environment, and to see my students enjoy that and experience that curiosity as well. And then the ideas they come up with, it's amazing. I mean, 25 minutes wasn't even near enough time to get into some of the other stuff that we're doing here, especially with the Epaulette shark, but some of the other species. They're just so inspiring. I wouldn't have my research program without them. They really are the backbone, the foundation for what we have. We've maybe 30 papers over the past few years about sharks and climate change, and that wouldn't happen without them.
Yeah. Awesome. Well, Jodie, thank you so much. Thank you for taking us into the world of the Epaulette shark. And I'm really looking forward to seeing what the results are. I think either way, it's just a pretty darn cool shark, and definitely worth protecting, worth studying, and worth learning all we can about it.
Absolutely. Thanks, Joe, so much. Thanks for all of your efforts, and everyone for joining us today. This has just been such a fantastic festival. Thanks so much.
Awesome. Thanks so much, Jodie. Enjoy the rest of your day.